This is a video walkthrough for practice 8a, polynomial division and the remainder theorem. So what we need to do is explain the mistake in this synthetic division. So our dividend is x to the fourth times x to the third minus 4x minus 1, and the coefficients are listed right here in the dividend. However, we're missing a zero placeholder. So x to the fourth plus x to the third plus 0x squared minus 4x minus 1 is the dividend. So a zero placeholder must be used. So let's do our synthetic division correctly. The 0 of the divisor, 2, goes in the box, and our coefficients are 1 for the x to the fourth term, 1 for the x to the third term, 0 for the x squared term, negative 4 for the x term, and negative 1 for the constant. We're going to bring down the 1, times 2 is 2, add that column, times 2 is 6, add that column, times 2 is 12, add that column, times 2 is 16, add that column. So that gives us a result of x to the third plus 3x squared plus 6x plus 8 plus the remainder of 15 over the divisor of x minus 2, and that's our correct answer. In number 2, we're performing a polynomial long division, which means that the divisor goes outside of the box on the left side, and then the long division symbol, and 6x squared minus 13x plus 2 goes inside of the division box. Alright, so what I'm going to do is start with the first term divided by the first term. So 6x squared divided by 2x is 3x, and then 3x gets multiplied by the entire divisor. So 3x times 2x is 6x squared, and 3x times negative 5 is negative 15x. What I have to do at this point is go back and change the signs and add, which is equivalent to subtracting. So if we change the signs of the second term below and add, then 6x squared plus negative 6x squared is 0, so I'm not going to list anything there. Negative 13x plus 15x is 2x, and then I'm going to bring down the plus 2. Next step is leading term divided by leading term. So leading term 2x divided by leading term 2x is 1. And so I'm going to write a plus 1 up here on the top. Now I'm going to take 1 and multiply it by the divisor, and that result is 2x minus 5. But instead of subtracting, I'm going to change the signs of that 2x minus 5 and add. 2x plus negative 2x is 0, the 2 plus 5 is 7, so we have a 7 remainder, and that means that the result is 3x plus 1 plus the 7 remainder divided by the divisor 2x minus 5. In number 3, we have 15x squared plus 11x minus 1 divided by 3x plus 1. So 3x plus 1, the divisor is on the right, and in that division box, 15x squared plus 11x minus 1. Let's take a look at our leading terms. 15x squared divided by 3x is 5x. 5x times 3x plus 1 is 15x squared plus 5x. However, I need to go back and change the signs. So I'm going to change this to negative, and I'm going to change this one to negative. And then I'm going to add 15x squared plus negative 15x squared is 0, 11x plus negative 5x is 6 times x. Now I'm going to bring down the 1, and let's take a look at leading term divided by leading term. 6x divided by 3x is 2, so plus 2 would be the next term of the quotient. Now I'm going to take that 2 and multiply by 3x plus 1. So 2 times 3x is 6x, 2 times 1 is 2. So instead of subtracting at this point, I'm going to change the signs So I'm going to change this one to minus, and this one also to minus. Now, adding like terms, we get a -3 remainder, so that means that the result of this long division is 5x plus 2 plus the -3 remainder divided by the divisor of 3x plus 1. In 4, we have 2x minus 1 divided into 10x cubed is the first term, 3x squared is the next term, 0x is the next term, and minus 2 is the last term. It's important to have that 0 placeholder. First term divided by first term is 10x cubed divided by 2x, which is 5x squared. 5x squared times 2x minus 1 is 10x cubed minus 5x squared. I'm going to change the signs on that product and add, and that gives us a result of 8x squared. I'm going to bring down the 0x, and now first term divided by first term is 8x squared divided by 2x, and that is 4x. 4x times 2x minus 1 is 8x squared minus 4x. I'm going to change the signs on that result and then add, and that gives us that remainder of 4x. We're going to bring down the minus 2, and now we're going to divide again. 4x divided by 2x is 2, and 2 times 2x minus 1 is 4x minus 2. Now when we change the signs and add, we get a remainder of 0, which means there will be no fractional part to this result. The result is just 5x squared plus 4x plus 2. In 5, we have a cubic function divided by a quadratic function. So our divisor is x squared plus 2. And you can write a 0 placeholder there if you want, but we can avoid doing that if you are able to do this. And I think that probably avoiding it is good. I like to write a 0 placeholder for the dividend, but for the divisor, I'd rather not. Okay, I don't believe we have any placeholders for the dividend, x cubed, x squared, x, and the constant term. So first step is the first term of the dividend divided by the first term of the divisor. X cubed divided by x squared is x. Now we're going to take that result, x, and multiply it by x squared plus 2. That gives us x cubed plus 2x. But wait a minute, I don't want to put that 2x there. I want to put the 2x underneath its like term. All right. That's the thing we're going to have to be careful about if we don't use that 0 placeholder in the divisor. All right, so I'm going to change the signs of that product that I just wrote. So now minus x cubed and minus 2x, and we're going to add together. The x cubed minus x cubed is 0. 5x squared is being added to 0, so I'm just going to bring down the 5x, and then 3x minus 2x is 1x, or just x. I'm going to bring down this minus 9. Next, first term divided by first term is 5x squared divided by x squared, which is 5. Now 5 gets multiplied by the entire divisor. 5 times x squared plus 2 is 5x squared plus 10. I'm going to change the sign on each of the terms in that result that I just wrote, and then add 5x squared plus negative 5x squared is 0, and the next is x. And I made a little boo-boo there. I'm going to correct. Way back here when I did my subtraction, we had 3x plus negative 2x, which is actually plus 1x. Okay, so now I'm going to go ahead and add what I was going to add before. So 5x squared plus negative 5x squared is 0. x doesn't get added or subtracted to anybody, and minus 9 and minus 10 add up to minus 19. Last thing I'm going to look at is, can we do any more division? First term of the remainder here divided by the first term of the divisor. We can't actually do that division and come out with a quote-unquote whole number. So that means it's time to stop. So if it's time to stop, the result is x plus 5 plus our remainder of x minus 19 divided by the divisor of x squared plus 2. What you'll notice is the degree, or the highest exponent on x, of the numerator, or that remainder, is less than the degree, or the highest exponent on x, in the denominator of that fractional expression there. So we can stop dividing when the degree of that remainder is less than the degree of the divisor. In number 6, when f of x is divided by x plus 5, so I'm going to write that f of x is being divided by x plus 5, the result equals x minus 2 plus 4 divided by x plus 5. I'm going to multiply each side of this by x plus 5. When I do that, f of x over x plus 5 times x plus 5 is f of x, and then x minus 2 can get multiplied by x plus 5. And then when 4 over x plus 5 is multiplied by x plus 5, the result is just 4. So f of x is equal to the quotient times the divisor plus the remainder. X minus 2 times x plus 5 is x squared plus 3x minus 10. And then I'll add to that the 4, and f of x is equal to x squared plus 3x minus 6. In 7, when g of x is divided by 3x minus 2, the result equals 9x squared plus 6x plus 4. If we want to solve for g of x, we can multiply both sides by 3x minus 2. So 9x squared plus 6x plus 4 times 3x minus 2. Since the remainder is 0, we don't have to add the remainder. Now we need to perform that multiplication, and we can use a sort of a FOIL method. If we multiply the first terms in the parentheses together, we get 27x cubed, and then if we multiply the next terms times 3x, that will give us plus 18x squared, and then the next term times 3x would give us 12x, and then 9x squared can multiply by the negative 2, and that gives us minus 18x squared, and 6x can multiply by the negative 2, and that gives us negative 12x, and finally 4 can multiply by the negative 2, and that gives us negative 8. You may also want to explore the box method as a way to maybe multiply a little bit more in an organized way, I guess. 27x cubed plus, and then I have 18x squared minus 18x squared is 0. 12x minus 12x is also 0, and then that result is minus 8. So g of x is equal to 27x cubed minus 8 when we combine our like terms together. For 8 through 12, we're performing a synthetic division. The 0 of the divisor, which is 2, when x minus 2 equals 0, then x is equal to 2 goes in that box. The coefficients of the dividend next to it, so 3, negative 4, 1, and negative 7. And then skip a line, bring down that 3. 3 times 2 is 6. Add that column, that's 2. 2 times 2 is 4. Add that column, that's 5. 5 times 2 is 10. Add that column, we get 3. So the result here is the coefficients of the quotient, 3x squared plus 2x plus 5, plus that remainder, which is 3 over the divisor, which is x minus 2. In number 9, I'm going to place the 0 of the divisor in the box. If x plus 4 is equal to 0, then x is negative 4. And the coefficients of the dividend right next to it, 1, 3, negative 5, and negative 4. And then skip a line, bring down that 1. 1 times negative 4 is negative 4. Add that column, that's negative 1. Negative 1 times negative 4 is positive 4. Add that column, negative 1. Negative 1 times negative 4 is positive 4. Add that column, we get 0. Here are the coefficients of the quotient, and the remainder is 0. So the quotient is x squared minus x minus 1. In 10, we're dividing by x plus 1/2, and if x plus 1/2 is equal to 0, then x is negative 1/2. The 0 of the divisor goes in that box. Coefficients of the dividend, 4, 2, negative 6, negative 1, and 1 go right next to it. Skip a line, bring down that 4. 4 times negative 1/2 is negative 2. Add that column, that's 0. 0 times negative 1/2 is 0. Add that column, we get negative 6. Negative 6 times negative 1/2 is positive 3. Add that column, we get 2. 2 times negative 1/2 is negative 1. Add that column, we get 0. There's a 0 remainder on this one. Here are the coefficients of the quotient, which are 4x to the third. We have a 0x squared, so I'm not going to write that term, and then minus 6x plus 2. In number 11, x minus 1 is equal to 0 when x is equal to 1, so I'm going to put a 1 in the box. Coefficients of the dividend go right next to it, so 3 is the coefficient of x to the fourth. There is a 0x cubed, minus 5x squared, minus 1x, and minus 2. Skip a line, bring down that 3. 3 times 1 is 3. Add that column, that's 3 plus 0 is 3. 3 times 1 is 3. Add that column, that's negative 2. Negative 2 times 1 is negative 2. Add that column, that's negative 3. Negative 3 times 1 is negative 3. And adding that column, negative 5. Here are the coefficients of the quotient, which are 3x to the third plus 3x squared minus 2x minus 3 plus our remainder of negative 5 divided by x minus 1. In number 12, since we're dividing by x minus 2, I'm going to place the 0 of that divisor in the box. X minus 2 is equal to 0 when x is equal to 2. And then the coefficients of the dividend next to it, we have a bunch of 0 placeholders. So 1 belongs to the x to the 6th term as its coefficient. There is no x to the 5th term, so 0. No x to the 4th term, so 0 there as well. The x to the 3rd term has a coefficient of negative 8. The x squared term has a coefficient of 1. The x term has a coefficient of 0, and there is no constant term. So all of these, and then bring down that 1. 1 times 2 is 2. Add that column, that's 2. 2 times 2 is 4. Add that column, that's 4. 4 times 2 is 8. Add that column, that's 0. 0 times 2 is 0. 1, add that column, and that's 1. 1 times 2 is 2. Add that column, that's 2. 2 times 2 is 4. Add that column, we get 4. So here are the coefficients of the dividend, and that's going to start with x to the 5th plus 2x to the 4th plus 4x to the 3rd. There's a 0x squared, so I'm not going to write a term there, plus 1x, which is just x, plus 2, plus the remainder 4 divided by the divisor x minus 2. In 13 through 14, we're going to use synthetic division to find each function value. The value of f of negative 4 is the same as the remainder when dividing by x plus 4. When we divide by x plus 4, the 0 of the divisor goes in the box, and that's negative 4, which is the same value that we're plugging into our function f of x. The coefficients of the dividend, 2, 6, negative 7, and negative 2, go next to it. Skip a line, bring down that 2. 2 times negative 4 is negative 8. Add that column, that's negative 2. Negative 2 times negative 4 is positive 8. Add that column, that's 1. 1 times negative 4 is negative 4. Add that column, that's negative 6. Our remainder is the value of the function, so f of negative 4 is equal to negative 6. In 14, if we want to find the value of g of 6, that is the same as the remainder when we divide by x minus 6. If we're dividing by x minus 6, our divisor, x minus 6, is equal to 0 when x is equal to 6, so a 6 goes in the box for the synthetic division. The coefficients of the dividend, which is the expression we're dividing into, go next to it. So we have a 5 for the x cubed term, Negative 29 is the coefficient of the x squared term, 0 is the coefficient of the x term, and 1 is the constant term. So watch out for 0 placeholders. Bring down that 5. 5 times 6 is 30. Add that column, we get 1. 1 times 6 is 6. Add that column, we get 6. 6 times 6 is 36. Add that column and we get 37. The remainder is the same as the function value, so g of 6 is equal to 37. In 15 through 16, we're just going to use each piece of information to make a conclusion using the remainder theorem. Remember, the remainder theorem just says that when you divide by, for instance, x minus 7, the remainder that you get is the same thing as h of 7. So h of 7 is equal to 43 is equivalent to saying when you divide h of x by x minus 7, the remainder is 43. In number 16, if h of negative 6 is equal to 29, then when h of x is divided by the divisor of x plus 6, the remainder is 29. The previous two exercises which expounded on the remainder theorem are what we're going to use to do number 17 and 18. If when we divide p of x by x minus 3, that implies that the value of p of 3 has the same value as the remainder, so p of 3 is going to have to equal 0. Taking our function p of x from above to find p of 3 is 3 cubed plus k times 3 squared plus minus 5 times 3 plus 6, and that should equal 0. 3 cubed is 27. 3 squared is 9, so that next term is 9k. And then 5 times 3 is 15, and plus 6, and that should equal 0. So we have 9k, and let's combine some like terms together. 27 minus 15 is 12, plus 6 is 18. That's equal to 0. If we subtract 18 and divide by 9, k is equal to negative 2. In 18, p of x divided by x plus 1 has a remainder of 13 is equivalent to writing p of negative 1 equals 13. So we're going to take our function p of x and replace x with negative 1. Negative 1 cubed plus k times negative 1 squared minus 5 times negative 1 plus 6 should equal 13. Negative 1 cubed is negative 1. Negative 1 squared is 1, so that term is just 1 times k, which is k. Negative 5 times negative 1 is 5. And then plus 6 equals 13. Let's simplify. Negative 1 plus 5 is 4. 4 plus 6 is 10, so k plus 10 is equal to 13, and k must be equal to 3. In 19, if we're asked to find the remainder when f of x is divided by x plus 1, rather than actually dividing, we can use the remainder theorem to say that the remainder is the same as f of negative 1, or f of the 0 of the divisor. So that would be 3 times negative 1 raised to the 50th power, plus 2 times negative 1 raised to the 43rd power, plus 5 times negative 1, plus 7. When we raise negative 1 to an even power, the result is positive 1. When we raise negative 1 to an odd power, the result is negative 1. So now performing all the multiplications, we have 3 minus 2 minus 5 plus 7, and that remainder gives us a result of 3. In 20, we're asked to find the remainder when g of x is divided by x minus 1. The remainder, according to the remainder theorem, is the same as g of positive 1, which is the 0 of the divisor. So that result for g of 1 is equal to 2 times 1 raised to the 23rd power minus 5 times 1 raised to the 7th power plus 1 minus 4. 1 raised to any power is 1, so 2 times 1 is 2, 5 times 1 is 5, and then plus 1 minus 4, so that remainder is equal to 2 minus 5 is negative 3, plus 1 is negative 2, minus 4 is negative 6. In number 21, we're asked to perform a synthetic division and use that result to write the function in partially factored form. So we're dividing f of x by x minus 2. So the 0 of the divisor goes in the box, and we're dividing 1x cubed plus 2x squared minus 13x plus 10. And bring down the 1 times 2 is 2. Add that column, that's 4 times 2 is 8. Negative 13 plus 8 is negative 5. Times 2 is negative 10, and that remainder result is 0. So the result for our division is coefficients of 1, 4, and 5. So let's write what that result is. So when we divided f of x by x minus 2, the result is x squared plus 4x minus 5. Multiplying both sides by x minus 2, f of x is x squared plus 4x minus 5 times x minus 2. That's partially factored form because this factor could be factored again. In 22, we're dividing by x plus 3, so a negative 3 goes in the box for synthetic division. The dividend is 1x cubed minus 3x squared minus 11x plus 21. Bring down that 1 times negative 3 is negative 3. Add that column, negative 6. Negative 6 times negative 3 is positive 18. Add that column, that's 7. 7 times negative 3 is negative 21. Add that column, we get 0. That's our 0 remainder. So what just happened? We took our g of x and we divided it by x plus 3, and we got a result of x squared minus 6x plus 7. Multiply both sides by x plus 3, and we get g of x is x squared minus 6x plus 7 times x plus 3, so that is partially factored.